Hi all, and welcome back to part 3. In this part, we're going to be going over our introduction to plotting. So the first thing you need to know about plotting in Python is that we use the module Matplotlib. To use this module, we're going to need an import statement. So import matplotlib.pyplot as plt. Just like NumPy, this as plt part is optional. But if you don't have it and you want to use the module, you're going to have to write matplotlib.pyplot every time. So I really recommend using this shortened notation plt. Matplotlib has a few common objects that are sort of nested in a hierarchy. On the outside, we have the figure. And this is considered the outer container for plotting. You can think of it a little bit like in a scientific paper where you can have a figure, but inside of that figure, there are a lot of different little subplots, but it's still just one figure in the paper. Python's the same way. You can have a figure and you can have a lot of different subplots within it, but it's still just one object. Next up down, we have the axes. And this is what we would consider the actual graphs or the subplots within the figure. And like I said, the figure can have many, many axes and will still just be one object, but the axes will all be separate objects. The next step down, we have sort of the smaller customizable things. So we have the actual axis, so x-axis, y-axis. We have all the labels, the title, and things like that. And these are the things you format to refine your plot and make it as presentable as possible to present your data in the best way. So here we're going to create a figure with a blank axes object within it. We start with our import statement, import matplotlib.pyplot as plt. And then we say fig, ax. And what that's doing is just giving variable names for our figure and our axes. And then we say that's equal to plt.subplots. And then we put parentheses because that's a function. So what that does is it creates a figure with the variable name fig, and it creates this axis, which is actually what you see here, and that has the variable name ax, or ax. You can also create a figure with blank axes objects with a custom size, and you do that using the same import statement and almost the same function. So you have fig, ax equals plt.subplots, but now we're giving our function an argument. So we say fig size equals a size tuple. And this size tuple for me is 15, 5. And what that is saying is that the width is 15 and the height is 5. You can also create a figure with multiple axes objects, like I've been saying. And you do that by saying fig, x0, x1 in a tuple. And what that's doing is making sure that each of these axes has a name. And then you set that equal to plt.subplots. And then you give it the arguments n rows, or the number of rows. And in this case, I've given it 2. And then you give it the argument n calls, or number of columns. And in this case, I've given it 1. So what happens is we have 2 axes objects, here and here, and it's still just one figure. So x0 is here, x1 is here, and they're both within figure fig. So now that we've created these empty plots, let's go ahead and try a simple line plot with actual data. So we have our file path. We load our data with gen from text using all of our arguments. And here I've actually created a simple time array. So I use the linspace function, and I start at 0, and I go up to the length of our data divided by 10. And it will have the same number of objects as data. The reason I did this length of data by 10 is that there's a 6-minute frequency, so the length of data divided by 10 is approximately the number of hours of data that we have. So let's start by creating a figure with an empty axes object. We say fig, ax equals plt.subplots with our parentheses. And that's what it gives us. It's just a nice empty box. Next thing we do is plot our data on the axes object. And what that looks like is we say ax.plot. Notice that we're plotting it on that axes object. And we give it time in the x-axis, our data in the y-axis, and then we have a few customizable options here. So here I've created the color to be red. I said the line style is just a solid line. The line width is 2, and I haven't given it a marker, meaning that each point doesn't have something on it. It's just a line connecting everything. These are optional, customizable, changeable, but they do tend to make the figure more appealing and present better depending on what you're trying to highlight in your data. So we've put the data on the figure, but the plot isn't done yet. We still have to create title, labels, and format the figure a little bit. So here, this ax.grid with parentheses, I've created a grid. and then ax.setTitle sets the title, and you feed that a string. And here I've optionally given a font size. Next, you can set the axes labels. So we have set X label and set Y label, and we just feed both of those strings, and optionally we can give them font sizes as well. So this is what the final figure looks like, and it's our nice Seattle tides for about 600 hours. So now let's talk about a different kind of plot. Let's talk about scatter plots. Scatter plots are a little bit similar to line plots, except that they are usually not connected, and they sort of just have dots scattered about, as the name would suggest. To do a scatter plot, this is the function. We have plt.scatter. Note that this can also be the axes object that we are plotting on. And then we feed it an x, or in this case, it's salinity, a y, in this case, it's temperature. And then we give it these customizable things. In this case, I've given it a custom size. So these are not changing in size, but I've given it a changing color. So this pressure is a variable that changes, meaning that it will have a changing color. And then an alpha is a transparency, and it makes it present just a little bit better when things are all stacked on top of each other. So let's make that same scatter plot from scratch, starting with our data file in the drive. So we start with our data file in the drive. We have all our import statements for Matplotlib, NumPy, and Google Colab Drive, and we mount our drive so that we have access to our file. Next, we're going to look at our file using readline in order to sort of see what it looks like and get our format. And we can see here that there's about 20 lines of header. There's actually one footer line that we have to take care of. The separation or delimiter is commas, which hint CSV. That's always the case. And we will also see that pressure is in column 0, the temperature is in column 2, and the salinity is in column 4. And those are the variables that I'm most interested in. So with all of that information, we can load our data. We say data equals np.genFromText. We get our path. We skip our 20 header lines. We skip our 1 footer line. We give it our comma delimiter, and we just use our 0, 2, and 4 columns to get pressure, temperature, and salinity. I actually separate each of those columns in this final data array out into P or pressure, T or temperature, and S as salinity, so that I can keep track of those a little bit better. After successfully loading the data, we just need to plot it. And we start by creating our figure and axes object. So we say fig, comma ax equals plt.subplots. And here I've given it a figure size, so it's 10 inches wide and 8 inches high. Next, we do our scatter here. So we say ax, because notice we're putting it on our ax object, dot scatter, s as the x-axis, t as the y, and then our size is a constant 30. And then our C, or our color, is P, or our pressure, which means that it's going to be changing in color depending on the pressure measurement that corresponds. And then our alpha is 0.5, and that's just saying a transparency of 0.5, which helps some of those dots not overlap. So the last step is going to be formatting the figure. So we have to set a title, ax.setTitle, and we give it a string. We give it X and Y label axes. So we have temperature and salinity as strings. And then we put on a grid. Notice that I've changed line style just a little bit and made it a dash dot instead of a solid grid line. And then finally, sort of something new, we create a color bar. So to do that, we say fig.colorbar. So we put it on the figure, not on the axis. And then we give it the plot that we just created, or the scatter plot, SCPL, and that's what we've named it up here. And then we give it the axes that it's on. So it's AX equals AX because that's the axes that we've plotted this scatter plot to. And then finally, I use that C.setLabel, and I give it a string and a font size in order to label this color bar so people know what those colors are corresponding to. So let's talk about the figure requirements for this course. Every figure you guys make, we expect a title, we expect axis labels with units whenever possible. We expect appropriate axis limits and appropriate tick resolution, both of which Python sort of does already, but you just need to watch out for big gaps on the end here. And then we expect legends for different data sets when applicable. We expect color bars for changing colors, things like that, anything that will notate what we're actually looking at in a plot. And then finally, we were looking for font sizes that are large enough to read. Aside from those objects, everything is customizable when you're plotting. You can change tick tick labels, you can change the title, you can change the line width, you can change just about anything as long as you know how. And you can usually find out how by searching the documentation or searching the internet on things like GitHub or Stack Exchange or things like that. Here, I've linked the official Matplotlib documentation. If you guys want to peruse it, there's a lot of arguments for any of these functions for plotting. That's it for part 3 and for this lesson 7. Here are the resources that I have sort of used. I will see you all in class.